Good day, gamers. I'm a member of Myopic and I'm excited to present Cosmic Kraken Adventure to you. Our game is an endless runner that utilizes low poly models, clever shaders, and simple lighting for some cool visual effects while running. The goal is to run for as long as possible to score the highest points in 3 different scene designs to keep things interesting. We'll notice some things that are common across all 3 levels. We have the main menu that allows you to play, pause, restart, and select the scene you want to play in. The menu also adds a touch of personalization for a player. You can take a photo of yourself or whatever you want and display it in-game while you roll. We achieve this through a custom-made photo-taking module in our game that uses custom shaders to apply filters to your photos, allowing you to add cartoonish styling to your image and let it blend in with the visuals of the game. All levels have an eyeball model, which is our runner. This eyeball falls from the Kraken model, which we create from scratch. The eyeball presented a challenge between balancing a good-looking eyeball and performance. We carefully selected the model so that we had a cool eyeball with a lower number of polygons for good performance. Seeing as the eyeball is the main character of our game, it was crucial to get this balance right. A slow and laggy endless runner wouldn't be all that fun to play. We then have a dynamically generated endless path. As you can see, this path extends all the way into the horizon, while obstacles are randomly generated and placed as you move, so that no 2 runs are the same. It's important to note that we put a lot of effort into making sure that the obstacles didn't stack on top of each other, which was a problem we faced with the random generation and placing. Furthermore, we had to ensure that players didn't dodge one obstacle only to run into another. Each scene gets progressively faster as you roll, as is the challenge in endless runners. You can move left and right across lanes using the arrow keys on the keyboard and jump using the up button. We had to decide if the longer length of a jump due to increasing speed would be incorporated as a feature or adjusted. We ultimately decided to adapt the jump length so that it stays the same even with the increasing speed of the run, as longer jumps pose the risk of landing the player on top of another obstacle. We had to fine-tune the code several times to maintain the randomly generated obstacles while preventing unavoidable obstacles. We created a coin meter feature. For every 10 coins that you pick up, it allows you to gain immunity from all obstacles and speed up significantly for a short period of time to score more points. Every level has an HDR image loaded in as the skybox. We have 3 main lights for each scene. Hemisphere lights were used to simulate ambient lighting to suit the different types of colors we had for the ground and sky in each scene. Point lights were used mainly in the regal theme to simulate the disco-like points of light you'll see in the scene. And directional lights were used to simulate light coming from the sky, such as a sun or moon, as our skybox images didn't influence the lighting very heavily. Our skyboxes are made by loading an HDR image into the HDR loader 3.js provides and setting that as the scene's background. Since we couldn't find high dynamic range images in the style of our game with proper lighting information to interact with our scene, we had to create these effects manually, as we explained previously. I'll walk you through the first scene of our gameplay. As you can see, we went for a whimsical and optimistic theme. We made sure to use bright and vibrant colored elements. One of the most notable things here is the manually created rainbow in the sky. Furthermore, our water shaders are custom made for a water effect that wasn't too simple but fit the cartoonish style of our game. Another thing you may notice is the reflection of our skybox on the water. We do this by passing the skybox image texture to the water shaders and using that data to create the illusion of reflection across the water. Our second level takes on a darker, more regal theme. As you can see, the same water shader is used, but you'll notice the reflections are different to match the skybox of this scene. The path in this scene has a different pattern. You'll notice the point lights moving across the path of this scene. In the previous scene, the path pattern was achieved through a rainbow pattern shader, whereas this one uses actual light. These path patterns are achieved through shaders or textures with the goal of blending in with the theme of the scene. We added the pop-up walls as an extra challenge, as the stationary obstacle seemed a little too easy to dodge, especially during the slower startup phase of the run. You'll notice the different wall designs we chose to fit each level. These also appear on the path randomly, encouraging the player to keep alert and not get too comfortable. Finally, our last level is pretty extreme. Here, instead of water, we went with lava to drive home the fearsomeness of the scene. The lava effect is achieved through our custom-made lava shaders. We programmed the shaders to try to achieve the shifting and burning effect of lava. Furthermore, we custom-made the volcanoes you'll see in the scene by modeling a sort of volcano shape and applying some texture to it. That concludes the main features of our game. We hope you enjoy the game.